If you notice that my runtime has disconnected, so let me finish writing the code and then we are gonna reload our dataset. Now we finished from our finding the total number of cases. Let's now try to add some text to show it. Total cases where we just identified here. Okay. str string, which is total again. Cases. Center, let's set center section, okay. Also, choose the font size, equal to 12. Let's take a color as black, equal to okay. Now we're done from adding the text. Let's now add the how we can calculate the proportion. Let's first start by defining some variables. Let's call it no disease cases or proportion. Proper equal to ct.ilog. We'll take the array to take I, the value we created, and start from 0. And that is going to be divided by the total cases. And then we'll also multiply it by 100 so we can get the proportion. Let's do the same thing also for the disease proportion. Disease prop, we'll call it. Also, it's equal to look, okay. This time we'll go with the target variable, which is 1, where in our case, where it's in the where the patient has a positive heart disease cases. Also, total case will divide by total cases, and then we'll multiply it with 100. So these are the main calculations that we're gonna do. Also, we need to add also the text to present these values, the no disease proportion to each of these bars. So let's add one here. We'll start by defining like X text again. minus 2.2. And then we'll take the our case will take I, and 0 cases where the patient has no heart disease, plus 3. And then let's print no disease cases, drop, one F, and then we'll also take the percentage sign, then we'll close that. Center, let's set that on the center side. Mm-hmm. Bottom, let's set also the font size equal to 10. Color has to be black. So we're done from creating the text that's gonna present the proportion for the no heart disease cases. So I've just copy pasted the same code, but we're gonna replace this one 0 with one, which represent the cases where there's a heart disease. It's the same thing. Exactly. Lastly, let's add the exact count of each bar. We'll start again defining a text. Zero 0.2 t dot log. Let's take now for the negative cases. We'll divide that by 2. str. Again, we'll open this bracket here. Now let's set the position, which is equal to the center in our case. Center. Also, variable, so the parameters has to go on the center as well. As usual, the font size is 10. Equal to 10. And the color also set to black. I think we're done for the negative cases. Let's do the same thing now also for the positive cases. And let's see then. Now if we try to run this code, it won't work since, as I mentioned, that our runtime were disconnected. So let's go back and try to rerun our data frame. We have here our data frame, and let's also import our libraries. Load the data. Correlation. Now we can run our code. So this is how it looks, prior doing any customization. Let's see now the updated version where we have added more details such as the total number of cases for each category with its proportion. Hopefully that we haven't made any mistake. So I added some comments to our code so it can be more readable and understandable for the people that gonna read your code. It's very important, to keep your code readable. So I've imported also some basic libraries that we're gonna need as Pandas and Matplotlib. So here, as we mentioned, the first function was to create a crosstab, to visualize the relationship between the chest pain type and the heart disease status. We set that to a CT, and then we created a bar, a plot, the same one we were using here. We add some communication, then we added the total of cases and the proportion for each class, for each of the heart disease cases and no heart disease cases. We added also the number of total of each cases, where here we didn't have the total number of cases. The total number of cases for each class represent, like for the first case, around 50, and then for the second case we have around 78 cases, and here we have around 23 cases. So we'll add these to the plot so you can read it in a more easier way. Also, we calculate the proportion for each class for heart disease and no heart disease, and we also added the proportion percentage to the bars. Then we added the exact count for each bar, the totals. So let's now run this, see the results. Okay, that looks better than the first one, where here you have the total number of the first type, you have total of 50, and you have the disease cases. with its proportion around 82% out of the total here, around 41 cases out of the total of 50 cases for the first category. The second one, you have around 79% where the patient has a heart disease out of 87. The last one has around 70% out of total of 23 cases. So that has provided us some, key observation like, the first atypical angina where CP is equal to 1 appears to have the highest proportion of people with heart disease, 41 cases out of 50 people. The non-angina pain where the CP is equal to 2 also shows a significant association with the heart disease. As you could see, 69 cases out of 87 individual. The typical angina here, which present by CP is equal to 0, where it's the first type, which we call it as typical angina, shows a mix of people with and without heart disease, though it's more in common people without heart disease. Symptomatic where CP is equal to 3 has the fewest group and individual with total of 23 individuals, but there are more people with heart disease than without. Mhm. So this is how we can, visualize and find each of the data statistics that we're looking for. So and that will might help us doing the feature selection and for further analysis.